Hello everyone, my name is A.Khan. In this video we will discuss about memory device, a topic of digital electronics. Now what is memory devices? Computer memory is a physical device capable of sorting information temporarily, like RAM, that is random access memory, or permanently, like ROM, read-only memory, then PLD, PAL, PLA, GLA, FPLA, FPGA, CPLD, etc. Memory devices utilize integrated circuit, that is IC, and are used by operating systems, softwares and hardwares. Now comes the classification of memories. Memories are classified into registers, primary memory and secondary memory. The primary memory is further classified into RAM and ROM. Then the secondary memory is classified into serial access and semi-random access. For RAM, it can both read and write. RAM is volatile, it is temporary programs are used, and it is random access memory. ROM is also random access memory. It's used for only read option. It is also non-volatile and permanent programs are stored here. For secondary memory, for serial access, it is of magnetic type, CCT, that is charge coupled device. And for semi-random access, that is direct, are divided as direct access, CD, DVD, HD, etc. Then comes RAM. Random access memory is a volatile memory chip in which both read and write options can be performed. Random access memory, which can be read and written bipolar and MOS, that is metal oxide semiconductor, and static and dynamic RAM. So static RAM, what is static RAM? Static RAM is data value is retained as long as VDD is present. And random access, any location can read at a point in time. And SRAM can be built using either latch or flip-flop or by transistor. This is the diagram of a static RAM cell using SR latch. The array of storage cells used to implement static RAMs. But the select input for control, dual rail data inputs B and B bar, dual rail data outputs C and C bar. Then static RAM using BJT, that is bipolar junction transistor. The select X and Y input lines select a cell from matrix. The Q1 and Q2 are cross coupled inverters, hence one is always off while the another is on, as one is stored in the cell if Q1 is conducting and Q2 is off. A 0 is stored in the cell if Q2 is conducting and Q1 is off. The state of the cell is changed to a 0 by pulsing a high on the Q1 emitter. This turns off Q1. When Q1 is turned off, Q2 is turned on. As long as Q2 is on, its collector is low and Q1 is held off. Then comes dynamic RAM, that is DRAM. The diagram is given of a 1-bit DRAM cell. It uses MOS transistor and capacitor to store bit. It is more compact than SRAM. Refresh required due to capacitor leak. Slower to access than SRAM. Then comes the difference between static RAM and dynamic RAM. The SRAM uses transistor to store a single bit of data. DRAM uses separate capacitor to store each bit of data. SRAM does not need periodic refreshment to maintain data. DRAM needs periodic refreshment to maintain the charge in the capacitors for data. SRAM structure is complex than DRAM. DRAM structure is simpler than SRAM. XRAM are expensive than DRAM. SRAM are faster than DRAM. SRAM are used in cache memory. DRAM are used in main memory. Now, what are the advantages of RAM? It has no destructive readout, fast operating speed, it has low power dissipation, and it is compatible. Then comes ROM, that is read-only memory. It refers to computer memory chips containing permanent or semi-permanent data. Unlike RAM, ROM is also non-volatile. Even after you turned off your computer, the contents of ROM will remain. The block diagram of ROM are given below. It consists of a decoder, a memory array, control circuit, I/O data circuit, and column I/O, that is input output. ROM is different types of ROM is given here: mask ROM, PROM, that is programmable ROM, flash EPROM, and EEPROM. EPROM means erasable programmable ROM, and EEPROM means electrically erasable programmable ROM. Then comes PROM. The diagram is given. This PROM can be programmed electrically by the user but cannot be reprogrammed. It is used in control of electrical equipment such as washing machines, electric ovens. It is a diagram of bipolar PROM array. Then comes EPROM, that is erasable programmable ROM. This can be erased and reprogrammed. The EPROM cell is given in the diagram. Here an additional floating gate is formed within the silicon dioxide layer, that is SiO2 layer. The floating gate is left unconnected while the normal control gate is connected to the row decoder output of EPROM. The data bits are represented by the presence or absence of a stored charge. The initial values of unprogrammed EPROM cells may be all zeros or all ones. EPROM transistor cell diagram is given. Then comes EEPROM, that is electrically erasable programmable ROM. The diagram is given on the right hand side. It is a read-only memory whose contents can be erased and reprogrammed using a pulse voltage used in computers, integrated in microcontrollers for smart cards and remote keyless system. Next is a comparison between PROM, EPROM and EEPROM. For RAM, the category is read-write memory, that is in place electrically world level, it is electrically and volatile. And for ROM, PROM, EPROM, flash memory, all are non-volatile. ROM is read-only memory. Its writing mechanisms is mask. For PROM, EPROM, EEPROM flash memory, the write mechanism is electrically and category is read mostly memory for EPROM, EEPROM and flash memory. This is also a comparison of RAM and ROM. Like RAM is expensive, it is volatile, size is small. And EEPROM is expensive also. It is persistent and size is very large. And flash memory is cheap, it is also persistent and relative size is huge. So we can see the comparison of RAM and different types of ROM in the given figure. Then comes digital logic array. The first one is PLD. It is programmable logic device. A programmable logic device is an electronic component used to build reconfigurable digital circuits. Unlike ICs, that is integrated circuits, which consist of logic gates and have fixed functions, a PLD has an undefined function at the time of manufacture. The types of PLD are SPLD. It is the types of SPLDs are ROM, PLA, PAL, GL, CPLD, FPGA. PLD with AND OR array is given in the figure. We can see that an AND array and a OR array is given in the figure. Then comes PLA. It is programmable logic array. It is a kind of programmable logic device used to implement combinational circuit. It is a set of programmable AND gate which link to a set of programmable OR gate, which can then be conditionally complemented to produce an output. It has 2 to the power n AND gates for n input variables and for m outputs from PLA. There should be m OR gates, each with programmable inputs from all of the AND gates. The schematic example of PLA is given. AND gates and OR gates. It is an array of AND gate and array of OR gate. Then comes PAL, that is programmable array logic. It is a family of programmable logic device semiconductors used to implement logic functions in digital circuits. It consisted of a small PROM, and additional output logic is used to implement particular desired logic functions with few components. PAL devices have array of transistor cells arranged in a fixed OR and programmable AND. So the OR gate array is fixed and the AND gate array is programmable, used to implement sum of products binary logic equations for each of the outputs in terms of the inputs, and either synchronous or asynchronous feedback from the outputs. The schematic diagram is given where we can see the programmable AND array and the fixed OR array. Then comes GAL. It is a generic array logic. So GAL device was an innovation of the PAL and was invented by Lattice Semiconductor. Its primary benefit is, however, was that it was erasable and reprogrammable making prototyping and design changes easier for engineers. Then comes FPLA, it is Field Programmable Logic Array. It is this circuit of both the single level logic type containing a programmable and NAND gate array and the multiple level logic type containing a programmable or NOR gate array responsive to data from a programmable and NAND gate array has the programmable capacity for enabling certain device pins to switch between functioning as data output pins and data input pins. A sequential logic FPLA circuit containing the basic elements of the multiple level logic device has a plurality of JK flip-flops for on-chip data storage. All the features of an FPLA are controllable or controlled through its on-chip programmable circuitry. Then comes FPGA, it is Field Programmable Gate Array. It is an integrated circuit designed to be configured by a customer or designer after manufacturing, hence the term field programmable. The FPLG configuration is generally specified using a hardware description language HDL. Circuit diagrams were previously used to specify the configuration, but this is increasingly rare due to the advent of electronic design automation tools. FPGAs contain an array of programmable logic blocks and a hierarchy of reconfigurable interconnects that allow the blocks to be wired together. Like many logic gates that can be interwired in different configurations, logic blocks can be configured to perform complex combinational functions. Many FPGAs can be reprogrammed to implement different logic functions, allowing flexible reconfigurable computing as performed in computer software. The conceptual structure of an FPGA device is given in the diagram. Thank you for watching this video.